So here we go, geography, learning about the world we live in and how we interact. Get ready to learn something useful. So I'm Mr. Ray the teacher. There's my social media. Don't think I'll be using that second one, naughty Chinese Communist government. Oops, shouldn't have said that. They're very good. So here we are, geography. The topic will be basic skills, things you should know. The concept will be reading weather maps, synoptic charts, if you want to sound fancy schmancy. Also, don't forget to subscribe. New videos are up regularly, and there's my other social media. Let's move on with it. So, reading weather maps, synoptic charts, if you want to call them that. Basically, either of them, they are a diagram which show us weather patterns in a simple way. It uses information models and data, and from this we can understand and make predictions about what weather will be like in a given place. Just some important vocab: your hectopascal, written as a lowercase h, uppercase p, lowercase a. It's the unit of measurement for air pressure. And you've got your millibars, more or less the same. Generally speaking, 1 hectopascal equals 1 millibar. This does not mean megabyte in this context, and it's lowercase m, lowercase b. So we've got some various vocab. Air pressure, it's basically the pressure of the air above on a given area of the Earth's surface. So you've got your pressure going down on you. The average sea level air pressure is around 1013. That is 1013 hectopascals HPA or MB, depending on how you want to write it. You'll see HPA is a lot more common. Therefore, a high pressure system, anticyclones, is anything higher than that. It's indicated on the map with an H or a H, depending on how you pronounce that. Indicates good weather, so clear skies, little wind. The isobars increase towards the center, and wind generally flows away from the center of a high. Air moves in a clockwise direction north of the equator. For those of you south, it goes the opposite. So if you're south, it goes counterclockwise or anti-clockwise. It's an easy way to remember it: anti-clockwise, anticyclone. Flipping that around, low pressure systems, their depressions is anything lower than that number. So anything lower than 1013. Indicated on the map with an L, obviously, because L means low, and indicates rains, clouds, and high winds, or potentially those. The isobars decrease towards the center, and wind generally flows inside to the center of a low, and air moves in a counterclockwise direction north of the equator. For those of you south of the equator, it moves clockwise. Again, anticyclones, anti-clockwise for the southern hemisphere. That's anyone south of the equator. And if you didn't know, the equator is the line in the middle of the globe. And this is due to the Earth's spin and the Coriolis effect. So a little bit different if you might have seen that Simpsons episode where they flush the toilet. So there you go. Just put it in nice fancy boxes to make it easier for you to understand. Quickly read over that. So, anticyclones in the southern hemisphere, anticyclones spin anti-clockwise. If you're wondering, counterclockwise is just the standard American English for it. Things you learn. So H will go that way. Now, what is a trough? A trough is a relatively long area of low pressure extending from the center of a low pressure region. They can be aligned with showers, thunderstorms, and can also indicate unstable air. What's a ridge? A ridge is a relatively long area of high pressure, extending from the center of a high pressure region. They're kind of opposites. They tend to be indicative of fine or better weather. So again, a trough will indicate not so good weather. Ridge indicates relatively good weather. Generally, both are drawn as a dashed line or dotted line. So some more vocab. A front represents a boundary between two air masses. There's a cold front that's indicated by a blue line with blue triangles on them. Just think about icicles, and it's showing the direction of movement. So see that one there? The cool air is following there, and it's going in where those spikes, those icicles are pointing. And just in case I said it wrong, cold front. I think I said flint. And there you go. Another example. Cold air tends to follow a cold front. and a cold air mass pushes underneath a warm air mass, pushing it upwards, therefore forming clouds and rain. And a warm front, it's indicated by a red line with red semicircles on them, and it shows the direction of movement. There you go. So there's the warm air following the warm front. And there again, the warm air direction is again indicated by these semi-donuts, or these little semicircles. And warm air tends to follow a warm front. And a moving warm air of mass is replacing a cold air of mass. You know, things have to go somewhere. A front represents, again, a boundary between two air masses. An occluded front, they're cold fronts that can sometimes catch up with warm fronts because cool air moves faster as it's harder for warm air to push against cold air, which is denser. And these, in turn, merge together, as indicated as a purple line with alternating purple triangles and semicircles on it, with both facing the same direction. So there's your wind direction of the warm wind. Oh, the cold wind's caught up. And, ooh, blue and red make purple. So there's your magic. These are gnarly and they can indicate tropical storms or even cyclones. And there's your stationary front. This is the boundary between two air masses which are not moving because neither is strong enough to move the other. Hence the name stationary. See here, the red and blue hasn't merged to purple. It's like think of it as an arm wrestle between two winds, one cold front, one warm front, and neither's winning. So there you go. There's the cool air direction. There they go. And yeah, this results in windy weather. So the warm air moves again, the cool air wins again. And as you can see here, neither is really winning it out in this so-called windy arm wrestle. That's an easy way to remember it. It's indicated as a alternating cold front and warm front going in opposite directions. So look where these little icicles are going. Look where these red semicircle donuts are going. So there's the warm air going that way up, and there's the cold air going down, and they're still battling it out over here. Then we've got isobars. These represent wind speed. And wind has to do with air moving along the isobars. We name wind from where it is coming from, not where it's blowing. So there we go. That's a southwesterly wind because it came from the southwest, assuming that north is up. So here we go. This is southwesterly wind because it came from the southwest. If the pressure gradient is high, that is the difference between high air pressure and the low air pressure in air is bigger, the wind will be faster. High wind speeds are shown by isobars which are closer together. So look at those isobars here. They're pretty cramped up. Where I put the laser pointer. And lower spins are shown by isobars which are further apart. So see where I've circled those ones here? Look at the difference. See that line and that line? Yeah, it's quite far compared to these three lines which are pretty tightly packed. And rain, this can be indicated by blue lines like this, or just lines at all. So think of isobars as railway tracks for the wind. I guess is one. Now reading a synoptic weather map. So this is from the Australian Bureau of Statistics. It's never good to plagiarize. So there's my source. I did this a couple of weeks ago. There, the synoptic weather chart and weather maps there. There are your symbols. There's a warm front that's got warm air. There's the warm air direction. There's a cold front with cool air. There's some examples there. Let's get rid of now. Now we've got the high pressure system. So this is like fine weather, sunny. So we'll just circle up those H's. Yellow, yellow. You got your low pressure systems, which indicate rainy weather, windy. So this is a way you can probably beat the weatherman or beat the weather app if you actually look this up. Instead of just looking at the app, you could probably get it right, whether weather app or weatherman gets it wrong. But usually the weatherman reads off this chart. Moving along, the average air pressure is 1,013 hectopascals. And in Australia, the wind direction, H means anticyclones, go anti-clockwise. So the wind here would be going in anti-clockwise direction. And L, cyclones, mean clockwise. So there, if you're looking at the railway tracks for winds, those isobars, see that's where the wind's going. Around that high pressure system. Around this low pressure system, the wind's going in that manner. So that's why wind blows. Now you can get some certain questions asking where does the wind blow, which direction. So this usually helps a lot. And I'll just play through this animation. Just going over the different days. So you can see the weather patterns moving. All right, so let's wrap things up. So what did you learn today? If that's what someone asks you, please don't waste the taxpayer dollar. If you go to public school, you learned about weather maps, synoptic charts, and how to read them, and how they're useful because they help us visualize weather in a given area. Isobars can be thought of as railway tracks for wind. Just remember, cold front has cold air following it. Warm front's got warm air following it. Wind is the movement of air. High pressure system, that's anything higher than 1013 HPA, usually equals good weather. And lower pressure system, or low pressure system, is lower than 1013 HPA, and that means not so good weather. And yeah, you can beat the weatherman with this knowledge. So thanks for watching. Please subscribe and check out my other videos if you already haven't done so. Spread the word, tell your classmates, friends, and colleagues if this helped you out with your test. And check out my Patreon. Feel free to support me if this video helped you out. And watching the ads helps too if this channel's been monetized. And yeah, study hard for a bright future. And also special thanks and shout out to the following. So Ms. Byron and Mr. P and Mr. C. Those were my geo teachers that, yeah, just looked through my old geo books to see how this is done. And Ms. Tackins and Stage 4 Geo classes, this one was for you. And the weatherman, Tim Bailey, so Channel 10, he's a famous dude in Australia, really helpful. And yeah, anyone else that would have helped me out too, many thanks, muchas gracias. I'll catch you around, study hard, and see you for now. Bye.